Hey, this is Mr. Bechtel. One last time for the last worksheet that you guys are going to hear a video from me about, and that is worksheet H, solving systems of equations. Now, we've got two different ways of doing this, and so I'm going to try to show you both of those. But as we're looking at this, you've got a couple of these problems right here. Our first way of solving systems of equations is substitution. And the second way is elimination, or it's also called linear combination. Essentially, what you're going to be doing as we talk about the substitution, you're dealing with two equations with two variables in them. And one of the things that I think is kind of interesting is that anytime that you're going to be solving systems of equations, they could have up to 50 variables if you really wanted it to be. You would just need to have unique equations for every variable there so you could find one way or another to work through it. So if you're going to try to solve this and you had 50 variables, you would need 50 equations. Now, fortunately, we're only looking at two, which makes things a lot easier here. So as we only have two variables, we need two equations to be able to find the place where those two equations are true at the same time. Now, if we were to graph both of these, one of the ways that we could solve this would be to find the intersection point between the two lines. And if you went back to the way that we had for graphing lines earlier, that would definitely be a way we could do this. Solving it algebraically, though, what's great is that when you're dealing with something like this, you're going to have one of two different setups, really, for how you're going to be solving this. I'm going to do problem 2 for this one. Our first setup is when you have two equations, and for one of them, you have a variable that's already isolated. So in this case, we've got x already isolated on one side of an equation. And if you look, problems 1, 2, and 3 are set up in that similar fashion. Essentially, what you're going to be doing, since you're trying to find the place where both equations are true at the same time, you're going to look in the other equation and find that very same variable, because whatever value you get for x here should be exactly the same value that you're going to be getting for x here if what we're finding is the solution of the system. So what that means we're going to do is to take the value for x that we have right here, that y plus 9, we're going to substitute that in for this other x. Now that's going to take rewriting the problems because we're kind of running out of space here. But essentially the way that I like to think about doing it is that when you're substituting, the first thing that you're doing is replacing the variable with a set of parentheses to give us a place to substitute. So I'm going to rewrite this equation, -2, and where there was an x, I'm going to put a set of parentheses to give the place to substitute in. Now the rest of it's going to be the same, -3y equals 7. And then where that x was, I'm going to take the value that this is equal to, that y plus 9, and I'm going to put that into that set of parentheses because I'm replacing the x value with the other expression that it is equal to. Now, what we now have is an equation that has just one variable. So when we solve this, we can get the answer for what y is equal to in the system. So let's go about doing that. You distribute that -2 and you get -2y minus 18, because that -2 times +9 is -18, minus 3y equals 7. I'm then going to combine my like terms, -2y and -3y, and we're going to get -5y minus 18 is equal to 7. I've got to get that 18 over to the other side by adding it. The negative and the positive cancel out, and I'm going to get -5y is equal to 25. And then if I divide both sides by that -5 to cancel it out, I'm going to get that y is equal to -5. Now, problem we run into, sorry about that, you couldn't see that last part. The problem we run into for a lot of this is that we start to run into issues where people go, haha, I got an answer, I'm done. Remember, when we solve a system of equations, we want an x value and a y value. So we have our y. What you've got to do is substitute that back into the other equation to find out what the x value is that corresponds with it. So I'm going to bring that down over here and say that x is equal to, instead of that y up there, I'm going to replace it with my -5 plus 9. Now, the nice thing is most of the time when you do this last part, the substitution is pretty simple. -5 plus 9 is going to give us a +4. So my x value is equal to 4. Now, you could write your answer like this with just both things circled, or you could write the final answer as an ordered pair with your x value first and your y value second. This then would be the point on the coordinate plane where that line and that line cross, because it's the value that they both have in common, or the solution to that system of equations. So that's the way that you use substitution to solve a system of equations. Now, these three on the bottom here, they're set up in such a way that none of the variables are isolated like that. Now, you can absolutely solve these for a variable. I can take this and solve it for x. I can take this and solve it for y. We should be in good shape. But what we're really looking to do with something like this is to use what's called elimination. One of the things that we have as a property is that if you have two equations that are equal at the same time, then we can create a third equation by basically adding or subtracting both sides of that equation. Because you're essentially saying this is equal to 8, this is equal to 4. So 8 plus 4 would be 12 here, just like 8 plus 4 would be 12 here. So we could totally get two different equations that would work. Now, it's great for this one, because if I add a positive 4y and a negative 4y together, that will cancel out my y's or eliminate that variable, and now I have an equation that just has an x and a number. And that's great. And that would be the way that we would solve this, just to add straight down, and then we would be able to deal with getting rid of our y variable. That being said, I'm going to use this one as our example because it's not quite as simple, and I want to show you what to do with that. 5 and the 3, those aren't going to cancel each other out if I add them together. 2y and negative y, those aren't going to cancel each other out when I add them together. So what I need to be able to do is to manipulate the equation in such a way that I can make it so that they can cancel each other out. Now, in the case of this one, I could absolutely multiply this one by a 3 and this one by a 5, and then I would have common coefficients. And I generally multiply one of them by a negative, the other by a positive, so that they're opposites when we add down. But it's a lot easier to work with this variable because all I got to do is multiply that one by a 2, and then I'll have a positive 2y and negative 2y, and when I add them together, they'll eliminate. What you have to do to change the equation to make it look like that is not just multiply that one variable by that 2, because they're not allowed to, it won't be the same equation. I'm going to take the entire equation and multiply both sides of that equation by 2, so that I'll have the right coefficient here, but then when I'm done, everything will change the exact same way, because that keeps it an equivalent equation, because we're dealing with the same problem. So I'm going to multiply everything by 2. This will be 6x minus 2y is equal to negative 4. So that is, as you can tell, the same equation. We just doubled everything. And then I'm going to rewrite this and scoot it over here. So we will have 5x plus 2y equals negative 29. Now, these two equations I have here, these line up with a positive and negative of the same variable. So since I'm going to be just combining these two equations to create a new one, I'm going to do that, and it should eliminate the variable that I want it to. So I'm going to put a little plus here next to it to show me that I'm doing that. 5x plus 6x is 11x. Positive 2y plus negative 2y is going to be 0y. I don't have to write that because it goes away. But for me, it's nice to put a little 0 there to let me know that it goes away. There's my equal sign. And then if I do negative 29 plus negative 4, I will get negative 33. Now, normally the equation that you get when you're done with this is super easy to solve. It's always like coefficient with a variable is equal to a number. You basically divide and you're in good shape. So here, I'm going to divide both sides by 11. Cancels out, and x is going to equal negative 3. Boom, we've got one of our answers already taken care of. Now, as I said earlier, we're going to need to be able to find out what the y value is too. So we're halfway there with this problem. At this point, since neither of these seems easier to solve than the other one, I'm just going to plug it in the top one because there's less crap around it, so it'll be easier. I'll rewrite that equation down here, but instead of the x, I'm going to replace it with that negative 3. So we've got 5. Instead of the x, I'm going to put parentheses to show they're multiplying. I'm going to substitute in that negative 3 because we just solved for what that was. Plus 2y is equal to negative 29. Okay, so there's my new equation. Y is the only variable, so when I solve this, I'll be able to get what that y value is equal to. This is negative 15 plus 2y equals negative 29. I'm going to bring that bad boy over to the other side by adding it. Why did I do 14? Oh, because I was looking ahead. Sorry. That cancels out. 2y equals negative 14. There's the 14 that I put in my own head for what's happening. And then if I divide both sides by 2, I get that y is equal to negative 7. So my final answer for this will be negative 3, negative 7 as a result for this. And so that's how you use elimination to solve a system of equations. You had substitution for the ones above. And so if you would go on and complete the other ones, that would be spectacular.